These three exercises in chapter 7, so exercise 5, 6, and 7, are all about using convolution to continue exploring feature detection in images. So let's start with exercise 5. Earlier in this chapter, I showed you how to use two-dimensional convolution with a Gaussian kernel to smooth an image. And we did that with this bathtub picture. There's the picture of not a literal bathtub, but this museum in Amsterdam, which kind of looks like a big bathtub from outer space. Anyway, the goal of this exercise is very simple. It's just to smooth the 3D picture. So it's the picture is represented as a three-dimensional matrix or a tensor where RGB pixels are in the third dimension. And earlier in the chapter, when we used convolution to smooth the image, I compressed the picture down to two-dimensional, and that was really just done for convenience, just to make things a little bit easier. So now we want to smooth the 3D bathtub picture. There's two different ways you can do this. One way is to construct a three-dimensional kernel, and a second way is what I write in the footnote, and that is to smooth each color channel separately. Now, three-dimensional kernels can be useful for some applications. They're used a lot in convolutional neural networks, for example. But in this case, I don't recommend using a three-dimensional kernel because that actually involves mixing the colors. So you're going to be averaging together the green and the red and the blue channels. And I think in this case, it's best to leave those channels separate. So we will convolve each of those layers independently of each other. Okay, and then I have another little heads up here that when you try to use plt.imshow, you're going to, with a three-dimensional matrix, you're going to run into some issues, so you'll need to convert the result into a different data type, uint8, so unsigned integers 8. So here we are in Python, and I start by initializing a matrix of zeros of the same shape, the same size as the bathtub matrix, this image here. Now, when you run this code, you're actually going to get an error message if you don't already have this variable loaded in. So if you haven't yet loaded in this variable, or if you are just coming into this code, you haven't run the code from the rest of the chapter so far, then you will need to scroll up to, where is it? It's here. This is the code where we import the image from Wikipedia. Okay, and then you see we have this variable bathtub. You can see it's 3 dimensions. So it's 1700 pixels wide, 3000 pixels tall, and 3 dimensions, which corresponds to the color, the RGB channel. And by the way, I just realized I said this the wrong way. So it's actually 1700 pixels tall and 3000 pixels wide. My apologies. Okay, so now we can scroll back down to exercise 5. Where is that? It's here. Okay, so very simple. We run convolution of each layer of this bathtub multi-dimensional array with the same kernel. And this is also a kernel. It's a Gaussian, two-dimensional Gaussian, which we created earlier in the book. That's also in the code that I just scrolled up to. Okay, so then we do this for each individual layer, and then we just show the picture, converting this. So this matrix gets converted into uint8. So it took a few seconds to run, and here you see the image smoothed. And just to make sure, this is just printing out the data types. We can run this. This is just so you can see the differences in data types. Now, the Python function imshow, the matplotlib function imshow, deals with floating point arrays if you have a two-dimensional array. If you have a three-dimensional array, it expects the format, the data type, to be different. So that's why we need to convert it here. Okay, and then here, this is not specified in the exercise text, but I just thought it would be nice to show the original bathtub and the smooth bathtub here, just to give you a reminder of what we have done. So this is the original image, and this is the smooth version of the image. You see the differences are really striking when you look at the buildings, for example, and the text. Here you see you can make out all the individual letters very clearly, and here it's rather smoothed. So if you like, you can try changing the size or the characteristics of the kernel, but actually that is what we are going to be doing in the next two exercises, basically playing around with different kernels for the different image layers.